evidence that there's definitely solid elements deeper into the earth beyond the crust. And then we just see physically what happens when any elements are placed in a microgravity environment, an environment that mimics a vacuum. We always see fundamental forces act on those particles and create a spherical object by pressing and compacting all of those elements together into a solid form, which kind of explains why the sun, the moon, all the planets are spherical objects. All of those elements are being compacted together. And you see pretty much any element added into that sphere is going to conform to it. But also what you're going to notice is the more elements that you add to the interior of that sphere, the less solid it becomes. You start seeing pockets or cavities forming within that sphere. All those elements mixing creates these voids within that sphere. And when we look at the earth as far below as the crust, this is something that we can definitely see. These deep extended cavities within the earth, which we see as caves and caverns. And we know most caves are made from water. When it becomes acidic, even if it's just the least bit acidic, over time it starts to dissolve that rock. And that's how these cavities or these openings start to form within that rock. And there's other ways that these cavities can form, but in general, wherever you have rock and some type of element or some type of force acting on it, you have the potential for caves to form. And we've got so many different people in the past saying that there are entrances deep into the earth at both the north and the south poles. And there's some evidence for this because, number one, when you spin spherical object in a constant motion at a high rate of speed, similar to the Earth's rotation, that sphere starts to flatten out at the top and the bottom and bulge out on the sides and basically becomes an oblate spheroid. And then if you put that same spherical object in a microgravity environment and you add elements into the interior of it and send it into a spinning motion at a high rate of speed, not only does it press down into more of an oblate spheroid shape, but the majority of the energy migrates to the center and extends to both the top and the bottom of the sphere and almost creates sort of a cylindrical mass right at the center of the sphere. So if the earth is spinning and taking on this oblate spheroid formation, you would expect to see something similar going on, but possibly on a larger scale because of all the electromagnetic activity and all the other forces acting on the planet. It would create this kind of like a torus effect where a good portion of the energy moves towards the center and extends out at the top and the bottom. And all of that energy and all that force will create cavities or holes at both the top and the bottom, at both the north and the south poles. In 2004, the Royal Astronomical Society actually takes measurements, magnetotelluric measurements, underneath East Antarctica and directly underneath the South Pole, and they release the results. Now, magnetotelluric measurements are basically taken by using the Earth's electromagnetic field to measure the depth of rock layers below a surface, in this case below the South Pole. And it's basically done by observing how those electromagnetic waves move through the rocks within a particular region. So they're basically measuring the rock layers below the South Pole. And when they released these results is when it got interesting, because you can see here what they ended up saying was our magnetotelluric results have provided some of the first definitive indications of sub-ice structure and physical state below the South Pole region, a substantial and widespread sedimentary section with significant porosity or matured organic content is inferred just below the ice sheet, corroborating earlier conjecture from refraction seismic data. So they're saying that there's a definitive indication of a substantial and widespread sedimentary section below the South Pole region with significant porosity. Now, in geological terms, porosity is referring to the percentage of open spaces or voids within a volume of rock. So basically, porosity is the amount of open space within rock. And again, they're saying that based off of their results, there is definitive indications of a substantial and widespread sedimentary section below the South Pole region with significant porosity. So a substantial and widespread sedimentary section below the South Pole region with significant open space or voids. And they're saying that they're already seeing this from earlier seismic data that had already been collected from this region. That when seismic waves hit this region, they were refracting as if they were hitting some sort of open space. Then it goes on to say, deep resistivity structure of the South Pole region at present appears to differ from that typical of cratonic lithosphere worldwide in exhibiting low resistivity in the lower crust and the upper mantle. So they're saying that the South Pole region is exhibiting low resistivity in the lower crust and the upper mantle. Now, again, from a geological standpoint, when you're talking about resistivity, you're talking about rock's ability to not erode, to not wear away, basically not to dissolve. And the porosity of rock basically determines that rock's resistivity. As the porosity increases, the resistivity of that rock also decreases. So in essence, the resistivity of rock decreases as fracturing and weathering increase, as porosity increases. And again, they're saying that their results show that below the South Pole, there is low resistivity in the lower crust and the upper mantle. So basically, there are signs of weathering and fracturing in the rock within the lower crust and the upper mantle below the South Pole region. And that low resistivity is because of that substantial and widespread sedimentary section below the South Pole region that is exhibiting a significant amount of porosity, a significant amount of open space or voids. So basically what it sounds like they're describing here is a deep cavernous region below the South Pole that extends down all the way past the lower crust and the upper mantle, which obviously would mean that it would extend down all the way to the mantle transition zone. And that what they see going on here below the South Pole within the cratonic lithosphere, which is basically that crust and mantle rock, differs from what can be observed from lithosphere readings in other parts of Antarctica and in other parts of the world. That this high porosity and this low resistivity in the crust and in the mantle are unique to the South Pole. And they believe it could be thermal activity underneath the South Pole that's causing the rock to melt, sending it into a liquid instead of a solid form, and basically making it indetectable. This is all theory. They really do not know why the porosity is so high and the resistivity is so low below the South Pole, but this is what they're seeing. And again, this is coming from the Royal Astronomical Society. And that was in 2004. Now, in 2022, the Lamont Doherty Earth Observatory announces this research initiative titled Imaging the 3D Viscosity Structure of the Antarctic Mantle with Existing Observations from GPS and Relative Sea Level, where they plan to map the viscosity of the mantle under Antarctica. Now, viscosity is the resistance to gradual deformation of a medium under shear stress. So in geological terms, a rock's ability to resist deformation, basically a rock's ability to not weather and to not fracture. And within this research, you can see that it says there exists extensive geological and geophysical evidence for significant lateral variations in viscosity and for the existence of low viscosity regions in the Earth's mantle below Antarctica that deform rapidly on decadal or faster timescales. Now, again, viscosity is a rock's ability to resist gradual deformation. And right here, they're saying that there is geological and geophysical evidence of low viscosity regions in the Earth's mantle below Antarctica that deform rapidly on decadal or faster timescales. So over the span of decades, these regions have been consistently eroding. And specifically, there's evidence for significant lateral variations in viscosity. Now, when you have low viscosity from a lateral angle, we're basically talking about lateral erosion, where that viscosity decreases and that rock starts to open up laterally, because lateral erosion is going to cause rock to widen. And it's basically going to cause gaps within rock to widen. And it's pretty much the same idea with vertical erosion, just in the opposite direction. And of course, when you put these things together, lateral erosion and vertical erosion, this is how you get large openings within the earth. Those cavities or cave-like regions deeper down in the earth. And again, right here, they're saying that there is geological and geophysical evidence for significant lateral variations in viscosity and for the existence of low viscosity regions in the Earth's mantle below Antarctica. So it's as if they are describing lateral erosion that has created a deep cavernous region, a large opening below Antarctica, leading to even more open space beyond the lower crust and beyond the upper mantle, down into the transition zone, down into that 660-kilometer discontinuity. It's almost like what is being described is a massive cave or a massive cavern 250 miles down into the earth, sitting in the middle of the mantle. And again, we know when you send a spherical object similar to the earth into a constant spinning motion, into a constant rotation, and you add an element to the interior of it, that spinning or that centrifugal force creates a cavity or a cylindrical mass at the center of that object that extends to the top and the bottom, or to the north and the south, to the north and the south poles, just like polar openings. And it makes sense if this is what they found when they got to the North Pole and they got to the South Pole during those early expeditions. Why, even after they signed that agreement to never shoot another nuclear missile into space, they still continued to set those nukes off at ground level, underground,